So Mark had already set the stage on what is the burning issue in front of us. We see the statistics frequently. 1.5 lakhs of death on Indian road a year. One death every 4 minutes. Really serious situation. Why is this? Is it because people drive very carelessly? No. There are a lot of factors that lead to this situation. And can we avoid this? Can we do something to improve the situation? So Mark also mentioned about the vision. The world is moving towards zero death, zero accidents. Is it possible? How do we move in this direction? The recent thing that you might have noticed is COVID has resulted in accidents and deaths. But that's not what we are looking for. Reducing the accidents by not traveling does not help us. The direction for us is how can technology or AI help in this regard? So I look at this space and see there are three different aspects that we need to closely watch. The first, how do we develop technology for vehicles, drivers, for the humans who is driving, and driving the movements? That is one set of technology or one set of problem. The second one is for human or more human-centric. There are a lot of social and cultural issues that causes these accidents and situation. How do we educate people? People now talk about, can we introduce the lessons in the schools on how do we behave better on roads? How do we drive on roads? How do we reduce the situation? How do we improve, educate the community? So we also know that a number of people who drive are not possibly trained to get the license in a systematic manner. How do we educate the drivers? Not only that, we also have issues related to the third dimension, that is the infrastructure. How do we improve the infrastructure? So improving infrastructure is not all about improving the roads or widening the roads, which has financial implications. Can we do better with our existing infrastructure? We have seen how technology has allowed us how to have better communication over limited infrastructure or the same infrastructure. How can technology help in improving the transportation, mobility, safety in Indian setting? So when we look at that, we immediately connect to what has happened in the past in the West. And is it possible for us to absorb the technology as such and deploy here? My immediate answer is no. Why? The picture tells it very clearly. The moment you look at the two pictures, you see what is structured and what is unstructured. We move in an environment where there are dense objects, new objects, unexpected objects, complex moving patterns, crowd, occlusion, poor visibility, a number of things that the typical AI algorithms today still struggle with. So this gives us a new opportunity for research, development, and moving forward. How do we do that? So if you would look at the AI as a framework for technology development, you realize that the way we want to look at the technology development is with the help of examples. So we have a number of examples, and we use these examples to build models or solutions, and use these solutions in deploy in a field and evaluate the performance on real data. So the advantage or disadvantage of, or the data-driven advantage of data-driven solutions are like you just change the data, the solution changes in the simplest form. The disadvantage is that the solution is only as good as the data that we have. So if you want to have solutions that are specially suited for India, we need to have data that capture the Indian situations. And if you look at the problems like driver assistance, so you want to have quantity of the data or the volume of the data. This is important, particularly that today's deep learning algorithms requires huge quantity of data. Quantity is not enough. You also need enough diversity and the data that captures the real world situation that we are looking for. See, this capturing this diversity has been a problem. And this is what the transfer of the technology from one world to the another world is stopping us. How do we do that? So this thought was validated experimentally. So if you look at this picture here, you see the picture on the left side, and the one that in the middle tells you how a computer or an AI algorithm should understand every small pixel in that picture. It puts in different color. The pixels on the roads are with one color, the human is with one color, the vehicle is with another color, the tree is with another color, sky is with another color. We want this capability for machines also to have, so that machines knows exactly where is a pedestrian, is somebody crossing the road. And if you use an algorithm that is trained on a data set that is captured in the Western situation and try it on Indian situations, as you can see, there's a huge error. Indeed, the way to address this is creating our own data. So if to characterize a little bit more clearly, so if you look at this, the diversity or the unstructured situation in India, you see a number of objects which we don't see in the Western roads. You see objects appearing in different forms, people at unexpected positions on the road. So you need to have a data that captures our Indian situations. This was the objective when we started the initiative of designing and building a driving data set for India, IDD. In collaboration with Intel, IIIT Hyderabad and Intel together has brought this IDD, the data set, one of the first in the world to address the mobility problems in unstructured driving conditions. It is getting extensively used worldwide now by researchers, and we have consistently seen that the top AI algorithms still find it very hard to get comparable performance on this dataset. And as a researcher, we enjoy hard problem solving. We enjoy datasets where the performances are inferior, giving us a lot of scope for working further. This dataset specifically has annotations. Human knowledge is captured in the form of annotations for a number of computer vision tasks, detection, classification, segmentation, etc. And a number of data types from various parts of the country it is captured for various tasks like perception, prediction, inspection, intent, all these different tasks that AI will be looking for. And this was used in top computer vision forums for challenges, top researchers, Indian students all of them have used, and we know where what's the performance. And with over time, the data set has improved, and now we have harder and larger versions of this data set. Can I request to play the video? Thank you. So the dataset is now publicly available. So the existing version, the dataset has data for detection, segmentation, multimodal data, and IDD light. This is an important aspect because the research and development with deep learning has become more and more difficult for common man. So we have created a light version which can be processed on laptops, enabling education, enabling rapid prototyping. And so this was also outcome of IDD. And of course, IDD temporal, which has the additional frames so that we can process videos. Moving forward, we are looking at what are the additional sensors that we need, more powerful and more detailed understanding of the surrounding. Popular low-cost sensing. So how do we develop data sets that are available for, say, driver assistance, a low-cost driver assistance, more infrastructure style of things. So this is another thing that we are presently working on. So what can we do with a simple camera? So this is the next question that we thought of asking. When you have a sensor, is it possible to extend this idea to practical situation around? This came in went on a rainy day, something like today in Hyderabad, where the roads were damaged due to heavy rain. We looked at, can we use similar technology for inspecting the quality of the roads, the damage on the road with scalable technology. So the idea was very similar of segmenting the images, but the classes now are for potholes, mud roads, and waterlogs and similar things. Indeed, this practical problem was also liked by the academic forums in this area. So can you place the video? So this video shows that a learned model is able to label the pixels with different color and estimate the amount of damage on different roads and map to the streets. Now, not only that, we can use similar ideas for inspecting on the road if you have a mobile phone camera on your dashboard or a dash cam. What can we do? We can estimate the street lights that are functional or non-functional, the signboards that are present, that are damaged, where they are, how far you can see from where, visibility of it. So a number of important aspects of our road infrastructure can be inspected with vision technologies. So you can see here a few examples of frames where the traffic signs were detected and how that get mapped on the road. You can also see how some of the traffic violations can be detected with a simple camera mounted on a car. Can you please play the next video? So this shows some of the violations. So you can see a simple vision algorithm is able to detect, say, traffic violations, people wearing the helmets, etc. So what we need beyond this? So you can see difference, what we need beyond. We need technologies for better driving, for the vehicles. Vehicle health monitoring, non-contact measurements, traffic detecting traffic violations, different type of violations that we see. How do we detect at scale? We need technologies for infrastructure, mapping, inspection, signals, visibility, maintenance. We need technologies for education and enforcement. How do we detect such violations and how do we participate in road safety as a community? We need technologies with Indian flavor. Most of the vehicles that are sold in India are two-wheelers and three-wheelers. What type of driver assistance and what type of technologies we need? And what are the associated cost and scale implications? What are the issues related to the human-machine interface in this space? So I look at this space as advantage India. We have a unique opportunity. We have a unique situation where we have a technological AI allows us to rapidly prototype solutions with the data, with the local data. So we should take this advantage, the new opportunity that we have, create data that we need to solve our problem, build solutions, use that data and deploy in our own environment. This is something that is feasible in today's situation. To summarize, I see this as the data, algorithms, and applications providing solutions that connects to the users in governments to startups. Thank you. Please join us in improving the safety, efficient, and enhancing the resources for mobility. Let us strive towards meeting the expectations set by our Prime Minister in bringing human intent and AI together to create a better society. Thank you.